Okay, so we're looking at trapezoids and kites, and like I said, today we're just going to focus on trapezoids. If I get into the kites, I will, but just to kind of make tomorrow's lesson a little shorter, but we'll at least get through trapezoids today. Just to kind of talk about, the categorization of this, keep in mind that last week we looked at parallelograms, right? And we looked at 3 special types of parallelograms, which were the rhombuses, rectangles, and squares. What we're looking at this week are the special types of non-parallelograms, okay? So we've got our big category right here is your non-parallelogram. Remember, to be categorized as a non-parallelogram, we need at least one of the pairs of opposite sides to be not parallel. If you have both pairs of opposite sides parallel, then it's a parallelogram, right? You can have one pair be opposite, that would be a trapezoid. So that's kind of the first thing to look at is, one special thing we have is if one of our pairs of opposite sides is parallel, but the other pair is not, then it's a trapezoid. Okay? Specifically, and we can get a little bit more specific. If I were to say, well, hey, not only do I have the opposite sides are parallel, or one pair of opposite sides are parallel, but if I also know that my non-parallel opposite sides are equal to each other, that makes it an isosceles trapezoid. So you can kind of think of an isosceles trapezoid as being like an isosceles triangle with the top cut off, right? All right, so let's talk about the kite. So the kite has no pairs of parallel sides, but what it does have are 2 pairs of consecutive sides that are congruent. Okay, notice that the opposite sides are not equal. It's the consecutive sides that are equal. Okay, a kite is exactly what you would think it would be based on what you fly in the sky, right? Okay, notice that a kite is not a rhombus though, so you do have one pair of sides. Whoa, sorry, that's not what I meant to do. You do have one pair of consecutive sides that are not going to be congruent. So not all 4 sides are congruent. Okay, let's look at trapezoids specifically. So trapezoids have kind of this notation that you need to, it's not hard notation, you just kind of need to be aware of it, because if I ask you to find the bases of a trapezoid, you would have to know what I'm talking about, right? So the bases are basically just the 2 parallel sides. We don't have any distinguishing words between like which base is what. It's just 2 bases. I might identify one as being the way it's oriented, the bottom base versus the top base. I might say the short base versus the long base. That might be how I decipher between the 2. But the 2 non-parallel sides are the legs. And base angles basically just have to fall on the same parallel line. So like the 2 base angles I've marked are base angles because they both lie on that bottom parallel line. You would also have a base angle up on this guy and then over here with that one. But it's a pair. So like, where's one pair of base angles on one parallel line, right? So yes, technically every angle is considered to be a base angle, but you have to be able to identify a base angle pair. Questions on that? Nope? All right. So a couple of properties that we get with the isosceles trapezoid is that you will have congruent base angles. Notice that this is specifically for the isosceles trapezoid and not just any old trapezoid, right? So any regular old trapezoid is not going to have these special properties, but an isosceles one with the symmetrical properties that it gets will. So when this says that the base angles are congruent, what that means is that these 2 base angles are congruent to each other, and the top base angles are congruent to each other as well. What do all the angles add up to in a trapezoid? Again, true for any quadrilateral, right? It doesn't have to be special to add up to 360. Okay. Okay, an isosceles trapezoid also is going to have congruent diagonals. What other quadrilateral has congruent diagonals that we've talked about before? A rectangle. Very good. So a rectangle also has congruent diagonals. The way you decipher between the two is a parallelogram with congruent diagonals is going to be the rectangle. A non-parallelogram with congruent diagonals is going to be your isosceles trapezoid. Okay? So for this one, we could draw in our diagonals. Take a look. I want you to kind of pay attention to the intersection of these. So when I draw these in a trapezoid, do the diagonals bisect each other? No. That's only in parallelograms, right? That they bisect each other. That will not happen in a non-parallelogram. In the isosceles trapezoid, what we do get to mark is that since these are congruent diagonals, I know that these pieces are going to be the same, so the upper end pieces will be the same, and then the lower end pieces are going to be the same. And the whole ones are obviously, so like the whole lengths themselves are also the same. Do you have a question? No? Okay. Yep. Mm-hmm. Thank you. All right, are there any questions thus far? All right, so let's take a look at the uses of these. So example 1, it just says to sketch an isosceles trapezoid. It doesn't really tell us, unfortunately, I didn't do a very good job of this. It didn't really tell us which side were the bases, so I'm going to put that information in right now so that you have it. I must have forgotten to type it in. Let's assume that the bases are CD and EF. Okay, so if I draw an isosceles trapezoid, I'll do this to my best of my ability. Okay, not perfect, but decent enough, right? So we're going to assume that this is isosceles. And then we're told that CD has to be a base. So if I'm going to start going around this figure, I might do C, D, E, and F. Keep in mind that I still have to follow around the figure, so I could not have done C, D, F, E, because it needs to go around in this order, right? That will screw me up if I switch those letters. All right. Look at what they're telling us. So they're telling us that CE is equal to 10. What is CE in this figure? It's a diagonal, right? So I know that this diagonal has a distance of 10. I also am told that angle E is 95 degrees. That whole angle. So the first thing they want us to do is find DF. That should be easy enough, right? So what do you know about, whoa, sorry, did not mean to do that. What do you know about the diagonals in an isosceles trapezoid? Isosceles trapezoid should have congruent diagonals. And I have the key word here. I am told that it is isosceles, right? So I know that this DF should also be 10. Okay, now the trickier part is finding all of the angles. I've given you one angle. Can anyone kind of help guide me in finding the rest? Which angle do you know right away? That's going to be really easy. F. You know that F has to be 95 degrees as well. How are you going to find the two base angles? Yes. Now, in an isosceles trapezoid, it is true that the consecutive angles are going to add up to 180. That is not going to be true in a regular trapezoid. So I wouldn't get hooked up on that. What I would get used to is in a trapezoid, all of the angles still have to add to 360, right? You have used 295s of that 360. Yeah? Which is, when you subtract that, leaves you with 170. You know that these base angles, since it's an isosceles trapezoid, have to be equal. So you would take what angles you have remaining. You have 170 degrees left to use, and you want them to be equally divided. That will give you 85. Does everyone understand the logic there? So you need all four angles to add up to 360. You need to subtract the 295s you've already used. That leaves you with 170 degrees to split evenly between the base angles. Questions on that at all? So these guys are both going to be 85 degrees. What? Yeah.
Couldn't you just go, since it goes over 5, you should just go under 5 and it's the same?
In the case of an isosceles, yes. If it was an isosceles, no. Yes, but in this case, yes. You're saying under 5 and over 5 of 180, right?
Yeah.
Mm-hmm.
The same for each one.
Yep.
Over 7, just go under 7.
Mm-hmm. All right, another property of trapezoids is this mid-segment business. So this is a new keyword you have to see. When you see the word mid-segment, you need to know, what do I mean by a mid-segment? What I mean by a mid-segment is the following. I mean that you find the midpoints of the non-parallel sides. So what are my non-parallel sides? BC and... You find the midpoints of those sides. So in other words, what I'm going to do is cut AD in half, find the midpoint, okay? So what I've done there is cut so that these two sides are equal right there, right? Do the same thing on the other side. So find the midpoint of BC as best you can. And then what you've done is you've cut that side in half as well. If you connect those two pieces, this is your mid-segment. So from here to here is your mid-segment. That mid-segment...
So we just eyeball this one, right?
Yeah, we're just eyeballing it.
Is there a way to get it perfect or no?
If it was a coordinate plane, you would find the midpoints using the midpoint formula. We're going to be doing more algebra work with this. So this mid-segment is going to end up being parallel to the two bases. So that's why I put the arrow there, is because this represents that it's parallel with these two. And the other special property is that this mid-segment is half of the sum of the two bases. Okay? So in other words, if this base up here were x and this base down here were y, and we're calling this our mid-segment M, you could write this a couple of different ways. Okay? You could say that the mid-segment is equal to half of the sum of the bases added together. Everyone see what I'm doing there? Take your top and your bottom base, add them, cut it in two, average them out. So basically you're finding the average of the two bases is what you're doing. How could I write that without a fraction? How could I write a similar equation without a fraction? Without a decimal. Just whole numbers. Rather than saying, so let me ask you this. I make half of the amount of money as Kate. Different perspective, Kate makes double. So what could I do here? Times what by 2? The M. So on the other perspective, double the other side instead equals x plus y. This is actually going to end up being a better form to work with when you have like x's and variables going on. the concept, so this is a better concept. If I just give you numbers, it's really easy to think about like, oh, add them up and take half. If I give you expressions, it's easier to work with non-fractions. You'll see what I mean on the next slide. But either of those you can use. All right, so let's look at this example. It says find the value of each base. If I want to know the value of each base, what do I need to find first? So what would you have to know in order to find the length of that top base? X. We need to find x, right? So we need to write a relationship about all of this. What expression could you write?
211 is equal to 5x minus 4.
Right, so he's saying, well, and the guys, the reason, let me write out the other one. So we have the two expressions. You could write that the mid-segment, which is 11, equals half of the sum of the two bases. So 5x minus 4 plus 3x plus 16, right? That was the first way I told you you could write it. Add up the two bases, divide them by 2 to get the average, right? The other way I told you you could write it would be to say 2 times 11, so double the mid-segment instead, equals 5x minus 4 plus 3x plus 16. Which one of these is easier to work with?
2 times 11.
Yeah. So that's what I was saying here is that this is just hard because then you're dealing with fractions, right? That's not going to be that useful right now, okay? So this ends up being 22 equals 5x plus 3x is 8x, 16 minus 4 is 12. Subtract the 12, we get 10 equals 8x. Divide by 8, and yes, you do get a fraction. That's okay. We do want to simplify this fraction, so what is that simplified?
1 and 2/8.
Let's leave it as an improper. 5/4, yep. Now can I find my bases? Yes, so my top base is just going to be 5 times my x value, which is 5/4, minus 4. So yes, you have to deal with fractions, but we've been dealing with fractions for a while now in life, so we can handle it. What is 5 times 5/4? 25/4. Yep. Keep in mind that this is technically over 1, so I'm not multiplying this 5 to both the 5 and the 4. This 5 goes here, this 1 goes here. So I get 25/4 minus 4. To condense this, I need to have a common denominator. How do I rewrite 4 so that it's in terms of force? Multiply it by 4, which will give you, okay. What is 25 minus 16? So our value there is 9/4. That's my top base, right? Okay. Your bottom base, you have a couple different ways you can find it. But the easiest is, what? That's only if you're solving an equation, because that's the length. You can't change the length there. If that was equal to something, you could multiply both sides by 4. All right. The easiest thing that you guys can probably do is just to follow similar suit here, right? Yep, I don't know if that makes sense, but we're going to go with it. Okay. So this is 15/4 plus 16. But I would want that to be in terms of force if I want to add it. So if I want to rewrite 16 in terms of force, what do I multiply 16 by? 4. What's 16 times 4? Good. What's 64 plus 15? And done. Okay. I'm about to a minute, so let me go to your homework slide. Don't run out of here until you see what you have to do. So we didn't get to the kites. We'll do that tomorrow. but you're going to do all of the homework that you can do with a trapezoid. So that is going to be the first 3 problems. You guys should do 18 through 22 tonight, and the last 2 problems, 51 and 52.
18 through 20.
Not 18 through, so 18, 20, 22. This is on Schoology, but you guys want to write down the 5 problems that I want you to do tonight. Those middle problems are going to involve kites. You can certainly go ahead, you guys, if you feel like you can look in the book and figure it out and you'd like to get the homework done and over with. It's not that hard. You can probably get through it. Otherwise, I'll teach to the kites in the next class period, and then we'll be good to go. Thanks, guys.